All right, it is time to review some factoring. Right now we're going to be reviewing factoring mostly quadratics. And there are a few different methods I want you to be aware of, but no matter which method you use, the first thing I want you to do is look and see if there is a common factor. So for example, looking at problem number 1, I see a 3, a 9, and a 36. All of those are divisible by 3, so that is definitely a common factor. Variables, I see x to the third power, x, and x. Okay, so they all have x's in common, and just go with the lower amount. So I see 3, 1, and 1. That means I can pull out 1x because they all have at least 1x. Now I see the y's. They all have y's in common too. Y, I see 1y, 2y's, and 1y. Well, they all have at least 1y. So this is my common factor, 3xy. So what you do is you pull that out in front of your parentheses. Now, to know what's going to go on the inside, one way to look at it is dividing. I could divide each term by the common factor. So I could divide by 3xy and see what I get. Now if I do that, the 3's cancel out. X to the third divided by x, that's going to leave x squared, and the y's cancel out. On the next term, 3 goes into 9 3 times. The x's cancel out, and one of the y's cancel out, but I'll still have a y there. And 36 divided by 3 is 12. So I'm definitely going to have a 12. And then the x's cancel out and the y's cancel out. So it's just 12. So this would be the answer for problem number 1. All right. You should look at the trinomial that's left behind and ask yourself if you could factor that further. The fact that this is x squared and this is a y makes it very unlikely that there's anything further we can do with it. And in fact, this is the answer for number 1. Now, when you glance at a problem and you see that it has 4 terms, the first thing you should be thinking is grouping. All right, grouping is where we make 2 groups. All right, we'll pair the first 2 terms as a group, and we'll pair the second 2 terms. Now, so we'll treat this as 2 separate little problems. The common factor from the first group is x, so I will pull out an x. Okay, and if I divide both of these by x, that's going to leave x plus 3. In fact, you know what? Let me use a different color. I'm going to use a different color for my parentheses. Okay, so that's going to leave x plus 3. Now, over here, the common factor is 5. So if I pull out a 5, all right, now if I divide everything by 5, that's going to leave x plus 3. Now, I purposefully made these both the same color to emphasize the fact that these are the same. So what we have here is the parentheses themselves are a common factor. So just like we pulled out the x and we put it out front, and we took the common factor 5 and we put that out front, we can take this common factor of x minus 3 and put that out front. So if I take this x plus 3 and undistribute it, put it in the front. So I've got x plus 3. Imagine if I took these away, look what would be left behind. And you can just see the blue is what would be left behind if I undistribute, factor out the x plus 3. So that will leave behind x plus 5. Okay, and so this is the factored form. All right, so that is how you factor by grouping. So watch out for that anytime you see 4 terms. Now, number 3, this is that special case called the difference of 2 squares. So this just follows that simple little pattern. C times C. I see 81. I'm thinking 9 times 9. And it's just going to be C plus 9, C minus 9. All right, that is the pattern of the difference of 2 squares. Okay, now for a trinomial like this, I see no common factor. When it's a trinomial, you should be thinking, well, this is probably going to be a binomial times a binomial. A squared is just A times A. All right, it's the only way to factor A squared. All right, so we looked at A squared first. And then we look over at the 3 second. And well, there's only one way to do 3. It's 3 times 1. So this is a relatively easy problem. So 3 times 1. Now, the inner terms plus the outer terms have to equal the middle. Right now, the inner terms, you know, I should do this in a different color. How about purple? Yes. Okay, so the inner terms here, I have 3a. Now the outer terms I have here, okay, are 1a, or just a. The inner plus the outer have to equal the middle, and the middle is negative 4a. All right, so I have to pick my signs in such a way that I will get negative 4a as a result. The inner plus the outer must equal the middle. All right, so at this point, I am really staring at this term, and I'm trying to get it. So hopefully you can see that if I had a negative 3 and a negative 1, that would make negative 4. Okay, so negative 3, that means I'll have negative 3 and a negative 1, and there's my negative 1. Always check one last thing to make sure this is the correct answer. Does negative 3 times negative 1 really give me positive 3? And of course, a negative times a negative is a positive, so I can be guaranteed that this is in fact the answer. Okay? Now, let's take a look at number 5. Same thing, no common factor, so I'm going to go ahead and think binomial times binomial, so m times m. Now, looking at the 40, this could be 4 times 10. Okay, what else could give me 40? It could be 2 times 20. All right, or it could be 5 times 8 makes 40, or technically it could be 40 times 1. All right, so these are all the ways that I can get 40. Okay, now I'm trying to get negative 3m, okay, for the middle. So if I kind of keep an eye on that as a shortcut, I'm going to, which one of these 4 am I going to probably try first? All right, well, I'm going to take a quick look at 5 and 8 because I know that 8 minus 5 is 3. So I'm seeing a connection there, and I'm thinking I could probably make this happen by using 5 and 8. All right, so let's go ahead with 5 and 8 for that reason. This sort of reasoning where we are looking directly, we're looking directly at these choices, this only works when the leading coefficient is 1, when there's no number sitting here. You can start looking right for the 3 or the negative 3 right from among these choices if there's no number here. When there's a number here like a 2, you really have to do the inner, outer, middle thing like we were doing before, okay, like we did on problem number well, I guess we haven't really fully done it. at all. All right, but that's coming. Anyway, the inner we have 5m. Outer we have 8m. Okay, and the middle is negative 3m. Okay, the inner plus the outer must equal the middle. All right, if I want this to work out, what do the signs need to be? All right, I need a negative result, so the bigger number has to be negative. So if I have a positive 5 and a negative 8, that will make negative 3. Okay, so there's my positive 5, and here's my negative 8. Does positive 5 times negative 8 equal negative 40? It does. So I can be guaranteed that this is my answer. All right, take a look at number 6. On number 6, are there any common factors? Nope, nothing in common. I see this trinomial, so again, I'm going to go ahead and start thinking binomial times binomial. 2n squared can only be 2n times n. That's the only way. Now, looking at the 3, all right, because that's where I'm looking next. Technical difficulties, no. All right, the program crashed, so I have to start that one over again. Where was I? Got the wrong color and stuff, man. It's really messed me up. So what we were saying was, this has to be. First, we look at the 2n squared, so that's got to be 2n times n. Then we look at the 3. All right, looking at the 3, there's only one possibility. It's got to be 3 and 1. Now, it matters the position. So it's either going to be 3 and 1, or it's going to be 1 and 3. All right, and again, the way we know the difference is the inner plus the outer must equal the middle. So right now, the inner is 3n. Okay, the outer, the way I have it right now, is 2n. Okay, and the inner plus the outer must equal the middle. The middle, all right, so now I am looking directly at this guy. Okay, because the inner plus outer must equal the middle. The middle is positive 7. So, the signs, man, the signs. In order to equal a positive 7, is there any possible way that I can pick the signs that will give me a positive 7? No. All right, if I made them both positive, that would give me 5, but I'm not going to get 7. That means 3 and 1 is not the way to do it. And this is why you use pencil. All right, because there's going to be a certain amount of trial and error involved. You're going to be doing a little bit of guessing and checking. So 3 and 1 didn't work, so let's go back and try 1 and 3 instead. Okay, erase, erase. Now, inner, now I have 1n. Outer, 2 times 3, I have 6n. If I choose the signs right, can I get 7 out of this now? Sure. If this is a positive 1 and a positive 6, that will give me 7. So there's my positive 1, and this making this a positive 3 will give me my positive 6 for the outer. One last thing to check. Does positive 1 times positive 3 equal positive 3? Of course it does, which makes this the answer. All right, look at number 7. We have a trinomial, no common factors, so we are thinking binomial times a binomial. X squared That's can only be x times x. Looking at 49, technically there's two possibilities. It's either going to be 7 times 7, or it could be 1 times 49. Obviously our first guess is going to be 7 times 7. Okay, now that gives us inner is 7, and outer is another 7x. Inner plus outer has to equal middle, positive 14x. Can we choose the signs right to give us 14? Of course, positive 7 and positive 7 will make 14. So plus and plus. Does positive 7 times positive 7 equal 49? Yes. That means this must be the final answer. Please make sure you always check that. And the very last thing you do, make sure that you're actually getting the last number. Okay, let's look at number 8. Okay, same situation. We're thinking binomial times a binomial. X squared can only be x times x. Now, 36. So we're looking at the 36 now. All right, so 36. This could be 6 times 6, or it could be 3 times 12, or it could be 9 times 4. It could be 36 times 1. It could be 2 times 18. Okay, these are all ways that I can get 36. All right, I think I've gotten them all. So these are all the ways that you can multiply two things together and get 36. Now, because there's no number in the front, all right, the leading coefficient is 1. We can do a shortcut and start looking for the middle term now. Okay, so the middle term, you know, I always say the inner plus the outer has to equal negative 20. But which one of these has a shot at giving us 20? 3 and 12, 15 is most we can get. 36 minus 1 is 35. 9 plus 4 is 13. 2 plus 18. 20. 18 plus 2 is 20. So our best shot is using this 2 and the 18. Now, going immediately looking for the middle term among these choices, a lot of kids try to do this all the time, but this only works when the leading coefficient is 1. Okay? Notice, like for example, looking back at number 6, we see the middle term is 7. A lot of kids will think this is prime because they'll look at the 3 and the 1. The only way to get 3 is 3 times 1. And they'll think, there's no way to get 7 out of 3 and 1. It must be unfactorable. But that's wrong, because you can't do that when there's a coefficient right here other than 1. You have to do the inner and the outer. And you see it really does work, because the outer is 6 and then the 1. So it's not really 3 and 1, it's 6 and 1. Okay, the inner outer thing still applies even to this problem. If you look at it this way, the inner is 2x. All right, the outer is 18x. Okay, the inner and the outer. And the inner plus the outer has to equal the middle. Now the middle is negative 20. So what do the signs have to be to make negative 20? The sign's right here. Don't look up here yet, just look right here. Okay, well, I would need a negative 2 and a negative 18 to make negative 20. They have to add up. So there's my negative 2 and my negative 18. Last thing to check, does negative 2 times negative 18 make positive 36? Yes, it does. So this is the final answer. Okay, looking at number 9. All right, is there a common factor? Well, 49, that's a 7 times 7. I don't see a common factor. And I am noticing that this is a perfect square. 49, that's 7 times 7. All right, that's 7 squared. 16 is 4 squared. So both of these are perfect squares. So that means this is the difference, subtraction, the difference of 2 perfect squares. Anytime you have the difference of 2 perfect squares, you are going to factor that as a binomial times a binomial. 49a squared, all right, that's 7a times 7a. 16 is 4 times 4. All right, for the difference of 2 squares, you are going to split it right down the middle. 7 times 7, 4 times 4. And then it's always going to be plus and minus. All right, every single time. All right, it has to be subtraction though, the difference, subtraction of 2 perfect squares. Okay, number 10. All right, every time I've been asking you, is there a common factor? And this time there actually is one, so be careful. I see the 2. 2 divides evenly into 50, so that is a common factor. So I'm going to take that 2 and put it out front. Always look for a common factor on every single problem. Now, if I factor out that 2, then remember that that means we're basically we're dividing by 2. That's going to leave behind x squared, because the 2's just cancel, minus 25. 50 divided by 2. All right, but this time we have to keep going because I recognize that x squared minus 25 is the difference of 2 squares. All right, so I have to take this x squared minus 25 and factor it just like I did number 9. So that's going to be x plus 5 and x minus 5. Now that 2 just comes down. All right, so the final answer should be 2 times x plus 5 times x minus 5. Okay, number 11. Trinomial, nothing in common, so I'm thinking binomial times a binomial. X squared can only be x times x. Now, looking at that 40, all right, the possibilities are, okay, I see 4 times 10. I see 2 times 20. And I see 5 times 8. And I see 1 times 40. Okay? Now, because the leading coefficient is 1, we can use that shortcut where we can immediately start looking for the middle value now. So the middle term is positive 18x. Which one of these can give me an 18 by adding or subtracting? 1 and 40? Nope, that'll make 41 or 39. 5 and 8? That's either going to be 13 or 3. 2 and 20? That can either make 22 or 18. I'm liking that. Please, please, please remember this process of immediately looking for the middle number, the middle term from among the factors. We can only do this when the leading coefficient is 1. It does not work when this is a 2 or a 3 or something else. But anyway, let's go ahead and go for it. So we're thinking 2 and 20. Now remember, the inner is 2x. The outer is 20x. And the inner plus the outer must equal the middle, which is positive 18x. What would the signs have to be to give me the positive 18 that I want? I would need a negative 2 and a positive 20 to end up with a positive 18. So there's my negative 2 and there's my positive 20. Check one thing. Does negative 2 times positive 20 make negative 40? Yes. So that means this is definitely the correct answer. Alright, looking at number 12. Once again, I see the 4 terms. When I see the 4 terms, I'm thinking grouping. Let's try grouping. Okay? So, let's form our 2 groups this way. Now, the common factor here is 2x. So if I pull that out, 2x. Okay, let's see what that is going to leave behind. Let me switch colors again. Alright, if I pull out a common factor of 2x, if I divide both of these by 2x, maybe I should show it. Alright, if I take this and I divide by 2x, okay, I am going to get the 2's cancel out and one of the x's cancel out. I get x. 2 goes into 12 6 times and the x's cancel out. So I have x plus 6. Alright, hopefully you can just do that in your head. Now here I see that 7 goes into both of these. I see that it's minus 7. So go ahead and think of it as a negative 7 that we are factoring out. Okay, that will help you. So if it is negative 7 that we are factoring out, so be so careful. Now as I go back, I'm going to make sure I divide by negative 7. Okay, so imagine that I divide by negative 7. Okay, obviously if those would cancel out and just give me x. Alright, but negative 42 divided by negative 7 is a positive 6. Very important, very important. So notice that I get the same factor twice, x plus 6 and x plus 6. We really would have been stuck as far as grouping goes if that didn't happen. Now that we see that we do have the same factor, we can factor it out, put it in the front. Okay, so I will pull off to the side my x plus 6. Now, if those x plus 6's are ripped away, look what's left behind. Okay, what's left behind will be what's shown here in blue, which is my 2x minus 7. Okay, so that is how you would factor that by grouping, and that problem is now done. Okay, let's take a look at number 13. Alright, I see the 3 terms and I see a lot of common factors. So let's definitely start by pulling out the GCF. Okay, looking at the 24 and the 32 and the 48. We are looking for the biggest number possible that divides into all of these. Now they're all even. So off the top of your head, you're thinking, okay, well, they're all definitely divisible by 2. Can we do better than that? What about 4? Yeah, 4 goes into 24 6 times, 4 goes into 32 8 times, and 4 goes into 48 12 times. Now, that's a terrible 4. Can we do any better than that? I know that let's see, 6 goes into 24, doesn't go into 32. I know 8 goes into 24, and 32, and 48. So it looks like 8 is going to be the winner. So let's go ahead and recognize that 8, as far as these numbers go, 8 is going to be the greatest common factor. Now looking at the variables, Here we have 8x's and 6x's and 4x's. All right, what's the lower amount that we just said? 8, 6, and 4. Well, 4. Okay, so we're going to include x to the 4th power. And then look at the y's. We have 4 y's and 2 y's and 7 y's. What's the lowest number we just said? 2 y's. So just always go with the lowest amount of variables, because that means, for example, with the y's, all of the terms have at least 2. Okay, because they all have to give away the same amount, and this term cannot give any more than 2. So 2 is the most that we can take out. So this is the GCF. All right, I'm just going to bring this down a little lower to make room for what I'm doing next. Okay, so fine. This is my GCF. Now, one way to look at it is to divide by the GCF. So I'm going to be dividing by 8 x to the 4th y squared. Let me zoom in. Okay, so again, I'm going to divide by 8 x to the 4th y squared, divide by 8 x to the 4th y squared. So if I do this, all right, 8 goes into 24 3 times. All right, these 4 x's are going to cancel out 4 of these x's and leave x to the 4th power. These 2 y's are going to cancel out 2 of these y's and leave y squared minus. All right, 8 goes into 32 4 times, right? 8 times 4 is 32. These 4 x's are going to cancel out 2 of these x's. These 4 x's are going to cancel out 4 of these x's and leave 2 behind. All right, these y's, both of these y's are going to cancel out, so no y's. Plus, okay, 8 times 6 is 48. So 8 goes into 48 6 times. The x to the 4th power is going to completely cancel out. And these 2 y's are going to cancel out 2 of these y's and leave y to the 5th power. Now, when I talk about this canceling out business, let me just make this clear in case anybody's forgetting. Okay, for example, focus on this part. All right, y to the 7th power over y squared. This really means y to the 7th power. 1, 2, 3, 4, 5, 6, 7. Y squared means y times y. So I'm talking about canceling out. Alright, so the 2 y's in the bottom are going to cancel out 2 of the y's in the top. But that's going to leave 1, 2, 3, 4, 5 y's. So you're basically subtracting, but I really encourage you to think of it as canceling out, like making 1. Okay, so that's what I mean when I say that. Alright, anyway, for number 13, this is the final answer. Okay, let's take a look at number 14. By the way, let me remind you, you should not be watching this video with a pencil in your hand. If you have a pencil in your hand right now, shame on you. Put that pencil down. Throw it across the room. Alright, if you're stuck and you need to watch the video for help, that's fine. But watch the video, get some ideas, and then go back and do the problem yourself. If you're just watching me and copying everything I do, you are learning nothing. And that's going to show up when we do the warm-up in class, and it's going to definitely show up on the test and the quiz. So do not watch this with a pencil in your hand. Okay, do it yourself afterwards. Okay, little speech there. So again, with the common factors, I see 2 is going to go into both of these. Okay, so I'm going to pull out a common factor of 2. And x is common to both, 1x. And they both have y, so I'm going to pull out the 1y. Okay, now let's see what that leaves behind on the inside. I'm not sure I left enough space. Okay, as I divide by 2xy, my common factor, everything canceled out. But that's not going to just be nothing. 2 divided by 2 is 1. Anything divided by itself, even 2xy over 2xy, is 1. So please put 1, not nothing. And then 72 divided by 2 is 36. This x is going to cancel one of these x's out and leave x squared. And then the y's are going to cancel out. So I've got this. Alright, so is this my final answer? Well, the fact that I'm asking the question is a hint. Can anybody see why this is not the final answer? Look at this red stuff. This is the difference of 2 perfect squares. 36 is 6 times 6. 1 is 1 times 1. It is subtraction, and of course x squared is x times x. So we need to continue this problem. We get to keep the 2xy, but we will factor the red part again. Alright, so 1 times 1 is 1, and we will have a plus and a minus. 36, as I said, is 6 times 6, and x squared is x times x. So it'll be 1 plus 6x, 1 minus 6x. Now it looks silly that I made the parentheses that big. Okay, so this would be the final answer for number 14. Got to go all the way down. Okay? Do you have a pencil in your hand? Do not watch the video with a pencil in your hand. Okay, in fact, if you came to this video feeling really stuck, maybe now you have some good ideas. So maybe now would be a good time just to pause the video and see if you can finish the rest on your own and then check back. Alright, but worst case scenario, you could do one at a time, but do not copy off the video. Pause, do a problem, come check. Okay, number 15 is looking easy peasy lemon squeezy. X squared can only be x times x. 9. Alright, it's either going to be 3 times 3 or 9 times 1. Because the leading coefficient is 1, I can go ahead and immediately start looking for that 6. So I'm thinking 3 times 3. Okay, inner, I've got 3x, and outer, I've got another 3x. Alright, to make a positive 6x, middle, I need a positive 3 and another positive 3. So boom, and that's it. Okay, so there's number 15. Number 16, ooh, be careful, we got the leading coefficient. Any GCF, common factor? No. So let's get to it. Alright, so we've got 3x and x. Alright, now 3 can only be 3 times 1. That's it. Now, let me let you in on a little secret. Because it matters whether or not I'm going to go 3 and 1, or whether I'm going to do 1 and 3. Okay? Because of this 3 here, that would give me 2 different answers. Now, Right now, you're going to learn how to, at a glance, know which one it's going to be. Either the green or the red. For example, I can tell you right now that it's going to be the red. Look, here's the deal. If there's no common factor in the original problem, there should be no common factor within the parentheses either. So, which one of these options is the right one? Which is the option that will not create a common factor? All right, the red is the way to go. Because imagine that we did the green. All right, let's just focus on that for a second. All right, I know right away that this 3 and 1 will not work. And the way I know it without even thinking about it is the fact that 3 and 3 form a common factor. There's a GCF, they're both divisible by 3. Even if this were a 6 or something like that, that still would count as a common factor because 6 is divisible by 3. So I know it's not going to be 3 and 1 in that order. It has to be the other way around. Because if I go with 1 and 3, then no common factor. No common factor. Alright, so if you follow that little hint, that will eliminate so many unnecessary choices. You don't have to waste your time. This will go much, much quicker. Anyways, this has got to be the way. Notice that everything is positive, so I know it's going to be all positive, but let me go ahead and go through the process anyway. Inner, we have 1x. Outer, 3 times 3, we have 9x. We're trying to get a middle of positive 10x. Of course, that will happen if we do positive 1 and positive 9. We'll pick positive 10. So there's my positive 1. And making this a positive 3 will make positive 9. And positive 1 times positive 3 is 3. So that's how I know for sure that this is the correct answer. Alright, let's take a look at number 17. So once again, it's looking like a trinomial, no common factors. Let's go ahead with the binomial times a binomial. 2x squared can only be 2x times x. Once again, 3 can only be 3 times 1. So it's either going to be 3, 1 or 1, 3. I'm just going to try 3 and 1 first. If this doesn't work, then I'll switch it and try 1, 3. Now, what do I mean by working? Is of course what we've been doing. Inner plus outer has to equal the middle. Inner, I've got 3x. Outer, I've got 2x. That has to equal the middle of positive 1x. Okay, so it's time to talk about the signs. What would the signs have to be to give me positive 1? Well, the positives have to win, so the bigger one has to be positive, and the smaller one would have to be negative, like this. So that would give me, that means this is positive 3 for my 3x, and this 1 would have to be negative 1, because that's where my negative 2x would come from. Alright, one last thing I have to check is, does positive 3 times negative 1 equal negative 3? And it does. Positive times negative is a negative. That means this is the correct answer. Okay? Now if you're checking your answer and you had something that involved 2x and 1, then real quick I'm just going to show you why that wouldn't work out. Okay? That is the answer. Now, let's see if we had gone the other way. So we had 2x and x. All right, 3 and 1 turned out to be the right answer. But what if we had tried 1 and 3? Let's see what would have happened. Inner, we had now 1x. Outer, we would have had 6x. And of course, we're trying to get positive 1x. And there's no way to get 1x out of 1 and 6. So that's why that didn't work. All right, let's move on to number 18. All right, I think I'll erase all this. All right, number 18, same type of thing. Okay, it's probably going to be a binomial times a binomial. So we've got x times x is x squared. All right, looking at 90, first thing that comes in my head is 9 times 10. And immediately I realize that 9 and 10, I can get a 1 out of that if I subtract. So 9 and 10 is looking pretty good. So let's go with that. Inner, we have 9x. Outer, we have 10x. And inner plus outer must equal the middle, which is positive 1x. So the signs. To make a positive 1, the positives have to win. So I'll make a positive 10 and a negative 9. So there's my negative 9, and my positive 10 comes from this guy over here. Now, check one last thing. Does negative 9 times positive 10 give you negative 90? Sure does. So that means this is the answer. Okay, let's look at number 19. Good old difference of two perfect squares. We can just do this immediately. Okay, 9 times 9 is 3. What did I just say? 9 is 3 times 3. X squared is x times x. 25 is 5 times 5. And so it'll be 3x plus 5, 3x minus 5. All right, it's always 1 plus and 1 minus. Okay, that's the pattern of the difference of two squares. Okay, back to business. Anything common? 12. 3 doesn't go into 16. Okay. Shoe. 12. Up until now, I've been nice. If I did give you a number in front, I gave you a prime number, like 3. So it can only be 3 and 1. But now, watch out. I'm giving you a number that is not prime. So we have to be careful with the 12 now. Now we have to consider the options. For example, 12. It might be 3 times 4. Or it might be 2 times 6. Or it might be 12 times 1. Okay, those are the possibilities that we have to think about. Of course, 3 can only be 3 and 1, so at least I was nice there. All right, but we'll have to do trial and error again with the 12. So I like to start with the two numbers that are sort of closer together. I always start with that. So for this 12, I'm going to start with 3x and 4x. You know, split it up. If this doesn't work out, I'll go back and try the 2 and the 6. And if that doesn't work, I'll go back and try the 12 and the 1. That's kind of the way I like to do it. So let's try this first. Now, we've got the 3 and the 1. Now, as I go to try this, am I going to try putting the 3 here and the 1 here? Or is it going to be the other way around? I am not even going to try putting the 3 here. Why not? common factor. Okay, if there are no common factors in the original problem, there shouldn't be any common factors in the parentheses. So I know this can't be right, so I won't even waste my time on it. Okay, that cannot be the answer. So when I do the 3 and the 1, I'll do 1 and 3. All right, if this doesn't work, that means the 3 and 4 option just is not working. So let's see what we have. Inner plus outer must equal middle. Inner, I have 4x. Outer, I have 9x. And I'm trying to get a positive 16 because that's the middle. Okay, is there any way to get 16 out of 9 and 4? No, the most I can make is 13, so that just didn't work. Okay, that means that the 3 times 4 option is not working. So let's go ahead and try the 2 times 6 option. So make sure you're doing this in pencil. Okay, so now we'll go back and try 2 times 6. All right, again, I have 1 and 3 to work with. Am I going to try 1, 3 or 3, 1? Am I going to leave it like this? Definitely not. Again, I'm not even going to waste my time on trying the 3 here with the 6 because that is a common factor. And if there were no common factors in the original problem, there should be no common factor in the parentheses. So I will not even waste my time putting the 3 there. I will try it the other way, 3 and 1. If it doesn't work this way, it just doesn't work. And I'll go back and try 12 and 1. Okay, let's see what we have. Inner, 3 times 6, 18. So inner, I have 18x. Outer, 2 times 1, outer, I have 2x. Aw, shucks, this is looking promising. I'm trying to get a positive 16. I can get a positive 16 out of this if I let the 18 be positive and the 2 be negative. 18 minus 2 is 16. Okay, this 18 comes from the 3 and the 6. So I'll make this a positive 3, and that will give me positive 18. That means this negative will have to have a negative 1, because negative 1 times 2 will make my negative 2x. Okay, last thing that I must check. Does positive 3 times negative 1 give me negative 3? Well, of course it does. Positive times negative is a negative. Therefore, this is the answer. Okay, that's the answer number 20. I don't want to do this for every problem, but let's just take a moment and talk about checking your answer. Here's how you would check your answer. Let's see. All right, say if you want to check your answer. You would take the answer that you got. So we have 2x plus 3 times 6x minus 1. And we're going to do a double distributive property and see if we get back to where we started. So for example, if I do 2x times 6 and 2x times negative 1. 2x times 6x is going to give me 12x squared. All right, 2x times negative 1 is going to give me negative 2x. Okay, now distribute the 3. All right, 3 times 6x gives me positive 18x. 3 times negative 1 is going to give me negative 3. Okay, these middle terms are like terms, so I can put them together. That's going to make positive 16x. Now I'm just going to bring down the other two terms. Okay, so I'm going to bring down my 12x squared, and I'm going to bring down my minus 3. Okay, does this match what we started with? 12x squared plus 16 minus 3, 12x squared plus 16x minus 3. That's match. Check. That means this is the right answer. Obviously, you probably don't have time to do that every single time you do a problem, especially on a test or a quiz. But when in doubt, check it out. Alright, man, this video is getting long. Alright, you know what? I knew this was a relatively long assignment when I assigned it. But the reality is you guys need the practice. So just deal with it, man. Okay, this looks like the difference of two squares again. 1 times 1 is 1. Alright, we'll have a plus and a minus. 81 is 9 times 9. So that'll be 1 plus 9n, 1 minus 9n. Difference of two squares. That's it. Alright, how about number 22? I'm seeing a common factor, x. So let's pull out that common factor. Alright, if I pull out that x, alright, and remember, I'm really dividing everything by that common factor, and that is going to give me x squared minus 9. Alright, once these x's cancel some stuff out. But guess what? This is not my final answer. Why not? Well, I'm going to keep that x, alright, bring that down, but this red part can be factored further, okay, because it is the difference of two squares, alright, it is x plus 3, x minus 3, so this will be the final answer. You got to go all the way down. Okay, let's look at number 23. Okay, no common factors, so here we go. Binomial times a binomial. It's like doing a puzzle. 5x squared. Oh, look at that. It was nice again. I gave you a prime number. So 5x squared can only be 5x and x. Alright, I'm taking it easy on you guys. Looking at the 6, alright, the first thing that comes to my mind is 2 times 3. If that doesn't work, then I'll try 6 and 1. But let's try the 2 and the 3 first. Okay, so it could be either way. Like maybe it'll be 2 and 3, or maybe it'll be 3 and 2. We'll just have to wait and see. Neither way makes a GCF, so we'll just have to see. It's all about the fact that inner plus outer equals middle. Inner, I have 2x. Outer, I have 15, 3 times 5. So outer, I have 15x. Okay, and that has to give me a middle of positive 17x. Obviously, if I can easily pick the signs to make 17, if I let the 15 be positive and the 2 be positive, that would make 17. So there's my positive 2, and positive 3 would make the 15 positive. Check one last thing. Does positive 2 times positive 3 equal positive 6? Well, yes, it does. That means this is the answer. Alright, don't believe me? Now I taught you how to check your answer. Alright, last one. Alright, can you believe this video is an hour long? Alright, hopefully you did not watch the whole video, just the ones that you got wrong. Hopefully you don't have a pencil in your hand. Again, if you have a pencil in your hand, shame on you. Put the pencil down. Throw it across the room. Okay, okay. Back to the easy ones. Super easy, okay? Leading coefficient of 1. X squared has got to be x times x. 64, first thing I think is 8 times 8. Alright, if this didn't work, there's plenty more where that came from. But, again, shortcut, when the leading coefficient is 1, alright, when there's no visible number in front, we can immediately start looking for that middle term now, right now. And 8 and 8 can make 16 by adding. So I'm betting that this is going to be the way to go. 8 and 8. Alright, and sure enough, okay, inner plus outer equals middle. Inner, I have 8x. Outer, I have another 8x. And that has to equal the middle of negative 16x. What would the signs have to be here? Well, hopefully you see that I'd need a negative 8x plus negative 8x to make negative 16x. Alright, so that translates into negative 8 and another negative 8. One last thing to check. Does negative 8 times negative 8 give me positive 16? Well, yeah, a negative times negative is positive. So that does work out. So that means that this is the answer for number 24. And this video is officially longer than an hour, so geez, you know what I mean? I hope this was helpful, and you know, you rewatch this as many times as you need to. You had 24 problems. It's a really good review of factoring. So I encourage you to do this over again a couple of times over the next week, and just make sure you can do every single problem on this paper without the video. Okay? If you've been copying the video this whole time, just tear that up, print up a blank copy off of Edmodo, and do it again yourself.